Thank you for that introduction. I'll try not to do feedback here. I just wanted to share a few things that are making me really optimistic and some directions on where I'd put my career if I was just starting out, and what I am doing actually to try to move things forward. So, the Anthropocene Institute, I like to say we're dedicating to trying to take care of our spaceship Earth and make sure it's comfortable and stable, for sure, with an engineering safety margin in case something unexpected happens. And as an engineer, that's actually a typical goal. But, you know, political institutions like the United Nations, they'd rather try to alleviate the worst consequences of climate change, maybe by adapting or mitigating them. They don't think about trying to solve problems or clean up the pollution that's bothering us. So I'll share 4 things. Next slide, please. I agree strongly with Chris Wright when he says we need more energy, because energy is the part of the supply chain we have control over. There is no actual shortage of energy on this planet, but we live in a world where there's a lot of regulatory capture, and what they call the free market is actually a giant cartel, and a cartel is the opposite of a free market. So change comes in what biologists would call punctuated equilibrium. It looks like nothing is ever changing, and then it changes really fast. And you know, when we hit the wall with climate change moving too fast, or when a big war comes up and people have to change the way they're doing things, that's when we get the opportunity to really fix things. Next slide, please. There's a big problem with the target, and I'd like to say just a bit about why we need more energy and why we need to restore ocean productivity first. And some of the opportunities that we've been looking at the Anthropocene Institute include hot, dry manufactured reactors and broadening the suite of nuclear technologies available every possible direction. Slide, please. So we live in an industrial society. Our life depends on our industry, and we shouldn't be ashamed of that or try to minimize that. In fact, if we make energy substantially cheaper, say 10 times cheaper, all of the really sticky problems turn out to be bonehead simple. We know how to fix all of our problems. We know how to clean up all our pollution. It just doesn't seem economic if you have to burn coal to make the energy. Next slide, please. These are the most important pollution issues that bedevil mankind and our environment. I only put greenhouse gases at number 2. Actually, the easiest to understand is ocean acidification and other changes to the ocean. It can be nitrogen depletion as well, oxygen depletion, depending on where. And that one you don't need a model to understand, because we know how soda pop works. Too much CO2 makes the water bitter. Plankton can't live in that condition, and that is reducing the amount of biology in the ocean by a substantial margin. But these other things are all really important, and the key thing is we can clean up every single one of those problems if we make energy substantially cheaper. So that isn't even necessarily hard. The only reason we haven't done it already is because the status quo industry is happy with the way things are. But we're not happy, so let's move forward. Next slide, please. I mentioned ocean productivity. So the United Nations and everybody has noticed that we're at 424 CO2. Since I made this slide, it's gotten worse. The historic safe level of CO2 is 280. And for some reason, the environmentalists in UN say we should keep it at 420 forever, which is what they mean when they say net zero is the goal. Net zero is not my goal. We gotta draw it down to a safe level and quickly. Meanwhile, we don't have enough seafood. You know, when I was a kid, you could go out and catch a fish and then keep it, but now they want you to throw it back. That's not fair. We have to get back our marine resources, and that will help draw down the CO2 if we do it right. Now, there are several ways to do it. My favorite idea is just create trillions of solar-powered, autonomous, self-replicating, pollution-eating nanobots. I think that's easy. Doesn't it sound easy? Kiko Toro here has been working on thinking this through from Scientific Development. Next slide, please. Actually, those nanobots exist. They're called phytoplankton diatoms, and all we have to do is make sure they have the right nutrients, and they'll spring into existence for us, as they do periodically, as that picture on the left shows from a satellite. And we actually have a shortage of whale poop. You know, the whales are 200-year-old wise creatures that have global communications network and GPS, and they poop just where the ocean needs more plankton to grow. And they farm it, and then they eat the fish that results. We can do that. Because we killed off 90% of the sperm whales. That's more biomass than all of the mammals that survive. We used it to make machine oil. Next slide. I'll finish up in a moment. One of the things that we need is nuclear energy. Never assume that public opinion is a manufactured product. We do research to find out what people are thinking about advancements in nuclear and other fields, and everybody's in favor of it now, even Democrats. Next slide, please. Don't apologize for health. People are right to be worried about their health, and that's where the main objections to nuclear came from. But nuclear saves so many lives. America has 1 million people alive today that would have been dead if we had used coal instead of nuclear. And worldwide, it's about 10 million. Next slide, please. There's a bunch of different kinds of nuclear that you haven't heard of. A lot of them just being invented. My favorite, actually I need to update this because of the changes at NRC and the Department of Energy recently. The second row there and the last row are the best ones. We've got Dr. Larry Forsley here who's been working on the last row, solid state atomic reactions, and that would be if there's a way in a crystal of metal to make a nuclear reaction happen, or at some small scale, fusion can be really viable at the small scale. But for the grid scale, fission is so great that I don't see any of those big fusion companies competing with fission if fission develops normally. You can't put fission in your basement, you can't put it on your airplane, so there's a lot of room for fusion. Next slide, please. The hot dry manufactured reactors, there's probably 20 or 30 kinds of them, and we're working on a bunch of them. Next slide, please. Here's just some of the examples of reactors that don't have water in them and run hot enough to connect to industry. Hot, dry, and manufactured brings down the price 10 to 100x and the quality up. Next slide. Okay, that's just a geeky thing on why solid state fusion is really hard to mathematically analyze, so the mathematicians of the world prefer hot fusion. Next slide. And next slide. So thanks very much for your attention, and that's what we've got. We can manufacture the power we need, and it's not going to be any trouble getting nuclear power to displace fossil fuels as long as it's 10 times cheaper. And if we make energy 10 times cheaper, we'll sell 20 times more energy, and the energy industry will make more money. That's, what's that? The Lazard's paradox? Jevons paradox, sorry. So go to the last slide, and I'll be done. Last one. Okay, this is Dr. Forsley's work right here, and we're so lucky to have somebody who's working on truly innovative fusion power, and it's not as hard as people think. Thanks a lot for your attention.